Capra. Nos parece casi increíble poder tenerlo aquí enfrente y degustar de esta comensalidad tan grande que vamos a tener en la tarde. Muchas gracias por su asistencia. Esperemos que disfrutemos mucho esta noche con el señor Capra. Muchas gracias.
Señor rector, hermano doctor Fritjof Capra, conferencista, invitado especial, autoridades de la Universidad de ULaSalle, profesores, profesoras, colaboradores, estudiantes del programa de doctorado, graduados del programa de doctorado, personas que nos visitan, tengan una cordial bienvenida a esta casa de estudios. Muy buenas noches a todos y todas. Me corresponde el difícil honor de presentar al doctor Fritjof Capra, nuestro conferencista de esta noche. Para hacer una presentación que haga honor al doctor Capra, tendría que hablarles por lo menos 2 horas, y ustedes han venido a escucharlo a él, por lo que he tratado de hacer un resumen de su vida académica, sus investigaciones y sus aportes, consciente de que mis palabras quedan muy cortas ante la trayectoria del doctor Capra. El doctor Fritjof Capra ha sido estudioso de Leonardo da Vinci, el brillante artista, científico, ingeniero, matemático, arquitecto, inventor, escritor e incluso músico, lo que evidencia que tenía una mente sistémica y un pensamiento complejo que le permitirían ver con claridad la irreductible interrelación entre todas las cosas y reconocer el entretejido de la vida. El doctor Capra señala que a partir del siglo XX emergen los conocimientos y el lenguaje necesarios para entender estas interrelaciones del mundo que ya Da Vinci comprendía en el siglo XV. Es así como en la actualidad se habla de los sistemas dinámicos, la teoría de la homogeneidad, la dinámica no lineal, la dinámica de redes y la teoría del caos para explicar y tratar de visualizar las redes que conectan todos los espacios de la vida. El doctor Capra también encuentra analogías entre sus investigaciones en física cuántica y su interés en la filosofía de la física cuántica con las filosofías orientales, mismas que han influenciado su pensamiento y sus propuestas. Es un investigador en física subatómica de las universidades de París y California, investigador en el acelerador lineal de Stanford y Londres y docente en varias instituciones de educación superior, y ha dedicado su vida a explicar al gran público las consecuencias filosóficas y sociales y el impacto que tienen en la biología y la ecología los más recientes hallazgos de la física. Sus libros, como por ejemplo El Tao de la Física, El Punto Crucial, Las Conexiones Ocultas y La Trama de la Vida, que buscan ayudar a alcanzar una nueva comprensión del universo, se convierten de inmediato en éxitos de venta. El doctor Capra ofrece cursos de física moderna para personas no especialistas en la disciplina y dice que le gustaría hacerlo incluso con niños y niñas pequeñas. Comenzaría, dice, de una manera poética y de los primeros encuentros les hablaría de la danza cósmica y cómo se relacionan todas las cosas. Él contribuyó con el guión de la película Mind Walk, Senderos de la Mente, que se inspira en su libro El Punto Crucial y que fue interpretada por Liv Coleman, Sam Waterston y John Fear. Recientemente ha llegado a nuevas concepciones científicas a servir de referencia para analizar e implementar el cambio que requieren las instituciones y las empresas. Sugiere que comprender cómo funcionan los sistemas vivos seguramente permitirá liderar con la complejidad que presenta. Él ofrece seminarios de gerencia para altos ejecutivos en Europa, Norte, Sudamérica y Japón. Esta semana está impartiendo un seminario sobre liderazgo y una nueva visión en la Carta de la Tierra y ha llegado a Costa Rica procedente de Brasil. El doctor Capra nació en Austria y su currículum dice que habla de manera fluida alemán, francés, inglés e italiano. El currículum de él no menciona que habla español, sin embargo, hemos tenido muchas reuniones y habla perfectamente el español. Él se encuentra aquí entre nosotros esta noche gracias al esfuerzo de la Carta de la Tierra y al programa de doctorado en educación de la Universidad de La Salle. El doctor Capra tiene una hija lasallista. Es un honor contar con su presencia hoy, doctor Capra. Con ustedes, Fritjof Capra.
Colegas y amigos, para mí es un grande placer de tener esta oportunidad de compartir algunas reflexiones con ustedes. Y también tengo que decir que este ambiente para mí es muy familiar, porque mi hija fue a una escuela La Salle durante 4 años. Entonces yo conozco bastante este ambiente intelectual. Pero una cosa no es vera, mi español no es perfecto. Y entonces no es suficiente para dar la charla en su idioma y tengo que continuar en inglés. Lo siento. So, as you have heard, I am a physicist and a systems theorist, and over the last 30 years I developed a conceptual framework that integrates 4 dimensions of life: the biological dimension, the cognitive, the social, and the ecological dimensions. I've presented summaries of this framework. I presented summaries of this framework as it evolved in 2 books, La Trama de la Vida and Las Conexiones Ocultas. My final synthesis of this conceptual framework was published last year by Cambridge University Press. And it is called The Systems View of Life. I wrote it with a friend and colleague, Pierluigi Luisi, who is a professor of biology at the University of Rome. This is a multidisciplinary textbook in which we present this integrated view of the 4 dimensions of life, and we also discuss the philosophical, social and political implications of this unifying vision. Let me begin with a word about these implications. As you know, the great challenge of our time is to build and nurture sustainable communities. What is sustained in a sustainable community is not economic growth or competitive advantage, but is the entire web of life on which our survival and well-being depends. In other words, I think I'm going to give up on this. slides. If you can get the third slide. Fourth slide. Next. Okay. So, in other words, a sustainable community is designed in such a way that its ways of life, its businesses, social institutions, economies, and so on, do not interfere with nature's ability to sustain life. This is the central point about ecological sustainability. Nature has sustained life for billions of years, and we must not interfere with this inherent ability. And of course, to do this, to build such sustainable communities, the first thing we need to know is how nature sustains life. We need to understand this. And it turns out that this involves a whole new conception of life. And this is the conception of life which has, in fact, emerged over the last 30 years at the forefront of science. And this is what Luisi and I are presenting in our book. At the forefront of contemporary science, the universe is no longer seen as a machine composed of elementary building blocks. We have discovered that the material world ultimately is an inseparable network of relationships, that the earth itself is a living, self-regulating system. The view of the human body as a machine and of the mind as a separate entity is now giving way to one that sees not only the brain, but also the immune system, the bodily tissues, and even each cell as a living cognitive system. Evolution is no longer seen as a competitive struggle for existence, but rather as a cooperative dance in which the creativity of life and the constant emergence of novelty are the driving forces. And with the emphasis on complexity, networks, and patterns of organization, a new science of qualities is now slowly emerging. Well, I call this new science the systems view of life because it involves a new kind of thinking. Thinking in terms of relationships, in terms of patterns, in terms of context. And in science, this kind of thinking is known as systemic thinking or systems thinking. It emerged in the 1920s and 1930s from a series of interdisciplinary dialogues among biologists, psychologists, and ecologists. In all these fields, scientists discovered that living systems, whether we talk about an organism, a social system, or an ecosystem, a living system is an integrated whole whose properties cannot be explained from the knowledge of the past. The so-called systemic properties of the whole are always different from the properties of the past. None of the properties have these characteristics. Let me give you a very simple example. You all know that sugar tastes sweet. Now, if you know some chemistry, you will know that sugar is composed of carbon, oxygen, and hydrogen. Does the carbon taste sweet? No. The oxygen? No. The hydrogen? No. So where does the sweetness come from? It comes from the pattern of relationships in that particular chemical compound that we call sugar. Now, sugar is not a living system, but it is an essential element of life, of course, and in living systems, this fact is even stronger. And so the early systems thinkers expressed this fact in the phrase that is now well known: the whole is more than the sum of its parts. System science also tells us that living systems share a set of common properties and patterns of organization. And this means that systems thinking can be used to integrate academic disciplines, which, as you know, have become very fragmented, by discovering similarities among systems of various kinds within the broad range of living systems. And this is why in our book we call the systems view of life a unifying vision. Now, during the 1970s and 1980s, systems thinking was raised to a new level with the development of complexity theory, technically known as nonlinear dynamics. It is a new mathematical language that allows scientists for the first time to really model complex systems and solve the corresponding nonlinear equations. Chaos theory and fractal geometry are important parts of this complexity theory. Now, this new mathematics, it turns out, is a mathematics of patterns, a mathematics of relationships. The solutions of nonlinear equations are not formulas, but are patterns, geometrical figures like this one here, and they're called attractors. This one is called the Vida attractor, and it describes a chaotic pendulum. And so this shape is a representation of the dynamics of the entire system. So complexity theory is really a mathematics of patterns and of relationships. And during the last 30 years, there has been a very strong interest in this nonlinear dynamics and in nonlinear phenomena. And this has given rise to several new powerful theories that have dramatically increased our understanding of many characteristics of life. And my synthesis of those theories is what I refer to as the systems view of life. Now, to represent it properly, we would probably have to all stay here for the whole semester. So I can give you only a few highlights. One of the most important insights of the systemic understanding of life is the realization that networks are the basic pattern of organization of all living systems. Ecosystems, as you know, are understood in terms of food webs, that is, networks of organisms. Organisms are networks of cells, cells are networks of molecules. So the network is a pattern that is common to all life. Wherever we see life, we see networks. Now, in fact, at the very heart of the paradigm shift from the mechanistic to the systemic view is a fundamental change of metaphors, from seeing the world as a machine to understanding it as a network. And this is also a source of great hope for me, because when you talk about networks and include social networks, which are, of course, networks of communications, then you know that our students, our young people, know these networks networks very well. They have grown up and they live in networks every day. And so this systemic thinking and this network thinking comes very natural. Now, closer examination of these networks, the living networks, has shown that their key characteristic is that they are self-generating. Technically, this is known as the theory of autopoiesis, created by two Chilean biologists, Umberto Maturana and Francisco Varela. Autopoiesis means self-making. In a cell, for example, all the biological structures, the proteins, the enzymes, the DNA, the lipids, and so on, are continuously produced and regenerated by the cellular network. Similarly, at the level of a multicellular organism, the bodily cells are continually regenerated and recycled by the metabolic network. So living networks continually create or recreate themselves by replacing and transforming their components. And in this way, they undergo continual structural changes while preserving their web-like pattern of organization. And now let me come to one of the most important and most radical implications of the new systemic understanding of life. And that is a novel conception of mind and consciousness, which finally overcomes the Cartesian division between mind and matter. You will remember that in the 17th century, René Descartes based his view of nature on the fundamental division between two independent and separate realms. That of mind, which he called the thinking thing, res cogitans in Latin, and that of matter, the extended thing, or res extensa. And then following Descartes, scientists and philosophers for centuries continued to think of the mind as a thing, some kind of intangible entity, and they were unable to imagine how this thinking thing is related to the body. The decisive advance of systems thinking has been to abandon the Cartesian division, the Cartesian view of mind as a thing, and to realize that mind is a process. This new concept of mind was developed during the 1960s independently by two scientists, Gregory Bateson, who was also part of the cybernetics movement early on in the 1940s, and Umberto Maturana, whom I have mentioned already. A few years later, Maturana and Varela, both working at the University of Chile in Santiago, expanded this key insight of mind as a process into a proper theory known today as the Santiago theory of cognition. During the past 3 decades, the study of mind from this systemic perspective has blossomed into a new interdisciplinary field known as cognitive science, which transcends the traditional domains of biology, psychology, and epistemology. The central insight of the Santiago theory of cognition is the identification of cognition, the process of knowledge, with the process of life. So cognition, according to Maturana and Varela, is the activity involved in the self-generation and self-perpetuation of living networks. In other words, cognition is the very process of life. The interactions of a living organism, plant, animal, environment are cognitive interactions. And in this way, life and cognition become inseparably connected. Mind, or more accurately, mental activity, is immanent in matter at all levels of life. Now, this is a radical expansion of the concept of cognition and implicitly of the concept of mind. In the new view, cognition involves the entire process of life, including perception, emotion, and behavior. And it does not even necessarily require a brain and a nervous system. Plants, for example, have no brain, no nervous system, but they are engaged in cognitive activity because they are self-generating living networks. Now, when you have such an advance in science, it is necessary to show that it actually helps explaining phenomena. Otherwise, you could say, this is just a play of words. So, you know, what's the difference? And in order to show the conceptual advance of the Santiago theory, one of the best ways is by visiting the very difficult question of the relationships between the mind and the brain, which has confused neuroscientists and philosophers for centuries. In the Santiago theory, this relationship is simple and clear. The Cartesian characterization of mind as a thing is abandoned. Mind is not a thing but a process, the process of cognition, which is identified with the process of life. The brain is a specific structure in complex animals and humans through which this process operates. So the relationship between mind and brain is a relationship between process and structure. Moreover, the brain is not the only structure through which cognition operates. The entire structure of the organism participates in the process of cognition. So, for example, concepts like muscle memory can be explained because muscles are living tissues that interact with the environment cognitively and have the capacity of memory. Now, I have been very excited about this new theory of mind, and I must tell you that it took me years and years to absorb it and integrate it. So, if you hear this for the first time, I don't expect you to just say, okay, and understand it and accept it. It's a very radically new theory. But what it does is, as I said, it overcomes this Cartesian split. So mind and matter no longer appear to belong to separate realms, separate categories, but can be seen as representing two complementary aspects of the phenomenon of life: process and structure. At all levels of life, mind and matter, process and structure are inseparably connected. Well, so far I've been talking about biological life. Now let's move on to the social dimension of life. Again, we can talk about living networks, but this time we are not talking about networks of chemical processes, we are talking about networks of communications. And this theory was developed by a German cognitive scientist, Niklas Luhmann, who used Maturana and Barella's theory of autopoiesis to create the theory of social autopoiesis. He showed that, like biological networks, social networks are self-generating. But what they generate is mostly non-material. Just think of having a conversation with several friends. And each conversation will provide maybe new information, new ideas, and it will trigger a response and lead to further conversations. And so this entire network of communications generates itself. And as the communications in this network continue, they form multiple feedback loops which eventually produce a shared system of beliefs, explanations of value and values. They produce a common context of meaning. This is what we call culture. And this culture is continually reinforced by further communications. And then through this culture, a social network turns into a community. And the members of the community assume certain identities as members of the community. And this is how the network generates its own boundary. I found it very instructive to, can we have the next slide please? I found it very instructive to compare these biological and social networks. You can say that biological networks operate in the realm of matter. Social networks operate in the realm of meaning. Both produce material structures. The whole infrastructure we see here, the building, the lights, the table, the chairs, this was all produced by some company, some organization, in other words, by a social network. So social networks produce material structures, but also they produce non-material structures. They produce the non-material characteristics of culture. Now, when you observe, say, a cell, then you will observe that the network of chemical reactions exchanges molecules. And the social network exchanges information and ideas in this network of communications. And finally, I haven't mentioned this when I talked about biology, a biological network, an autopoietic network, creates its own boundary. In the cell, that's the cell membrane, and the cell membrane, by letting certain molecules in and keeping others out, defines the identity, the molecular identity of the cell. So the boundary imposes constraints on the chemistry that takes place inside. Similarly, a human community, a social network, creates a cultural boundary that imposes constraints on the behavior of its members. This last part particularly, the nature and role of boundaries in biological and social systems, is very intriguing in my view and should be explored in much more detail. If you are looking for a topic for a thesis that is intellectually challenging and fascinating, there it is, boundaries in social and biological networks. And if you want to be even more ambitious, you can go on to boundaries in ecosystems, which is something that is very ill-defined, not very well defined. Much work needs to be done. Well, let me move on to the practical applications. This systems view of life is not just theory, but has many practical applications. And in fact, in the last part of our book, called Sustaining the Web of Life, we discuss the critical importance of systems thinking for dealing with the major problems of our time. It is becoming ever more clear today that these problems are systemic problems, which means that they're all interconnected and interdependent. Now, obviously, you can't read this diagram. It is produced on a whole page in our book. I just want to give you an idea of the complexity of how these various problems are all interdependent. Now, it seems to me that the fundamental dilemma underlying all these problems, and you see this on the dot in red, maybe you can read that, the fundamental dilemma is the illusion that unlimited economic growth and unlimited corporate growth is possible on a finite planet. This is a belief that is completely irrational, and yet it is sustained by most of our politicians and economists. You know, 1% growth is bad, 3% is better, 4% is great. Nobody in politics and economics seems to ever have heard of cancer, because cancer is rampant growth and is lethal. And this is something that we're now experiencing in the world at large, because this insistence on economic and corporate growth, which is the driving force of global capitalism, has led to social inequality and social exclusion, to increase of poverty, to excessive consumption, a throwaway economy that is energy and resource intensive, that generates waste and pollution and depletes the Earth's natural resources. Moreover, since this growth is based largely on fossil fuels, this has now led to climate change, which is the greatest danger that we are facing. So it seems to me that the key challenge today is how to shift from an economic system based on the notion of unlimited growth to one that is both ecologically sustainable and socially just. Now, some people say we should eliminate growth, we should have no growth, or we should have negative growth. But I think that's not the solution, because growth is an essential characteristic of life. All living systems grow. And so a society or an economy that does not grow will sooner or later die. However, growth in nature is not linear, nor is it unlimited. While certain parts of organisms or ecosystems grow, others decline. And when they decline and disintegrate, they release their elements, their components, which become resources for new growth. Now this balanced, multifaceted growth is very well known to economists and ecologists. I call it qualitative growth, to contrast it with the concept of quantitative growth measured in terms of this undifferentiated index of the gross national product, or GDP, which is used by today's economists. In fact, most of what is called growth today is waste. So that what we really have is an economy of largely waste and destruction. Qualitative growth, by contrast, is growth that enhances the quality of life through generation and regeneration. In living organisms, ecosystems and societies, qualitative growth includes an increase in complexity, an increase in maturity and sophistication. So we need to qualify growth. We need to distinguish between good growth and bad growth, and then we need to enhance the good growth and diminish the bad growth. Now, from an ecological perspective, This distinction is very easy. Growth that uses fossil fuels, excessive energy, toxic materials, growth that destroys local communities, increases economic inequality, all that is bad growth. And of course, that's most of the economic growth we have today. The opposite is the good growth. Growth that uses renewable resources, no toxics, no fossil fuels, is locally embedded in local communities and creates equality. Well, this is the good growth. And so this is a key to solving our economic crisis in my view. Well, to conclude, I want to return to the concept of ecological sustainability. Next slide, please. As I mentioned before, a sustainable human community is designed in such a manner that its ways of life, businesses, economy, and social institutions do not interfere with nature's ability to sustain life. And the first step in this endeavor is to understand how nature sustains life. So we need to understand the principles of organization, that ecosystems have evolved over billions of years to sustain the web of life. Knowledge of these basic principles of organization, or principles of ecology, is what is known today as ecological literacy, or eco-literacy. In the coming decades, the survival of humanity will literally depend on our eco-literacy, on our ability to understand the basic principles of ecology and to live accordingly. And this means that eco-literacy must become a critical skill for politicians, business leaders, and professionals in all spheres, and should be the most important part of education at all levels, from primary and secondary schools to colleges, universities, and the continuing education and training of professionals. And I'm very happy that I'm standing here in a university that practices this kind of teaching, and moreover in a country that also practices this kind of teaching and this kind of knowledge. Just to give you a brief summary, what we need to teach our children, our students, and our political and corporate leaders, if you wish, are the basic facts of life. For example, that one species waste is another species food. That matter cycles continually through the web of life. That the energy driving these ecological cycles flows from the sun. That diversity assures resilience. And that life, from its beginning, more than 3 billion years ago, did not take over the planet by combat, but by networking, by partnerships. Well, eco-literacy is the first step on the road to sustainability. The second step is to apply our ecological knowledge to the redesign of our technologies and social institutions in order to bridge the gap that now exists between the sustainable systems of nature and human design. And this is known as eco-design. To practice design in this way requires a fundamental shift of our attitude toward nature. A shift from finding out what we can extract from nature to finding out what we can learn from her. And as you know, there has been a dramatic rise in ecologically oriented design projects and practices in recent years. In our book, we review these practices and projects in some detail. In particular, we discuss 3 different but mutually compatible models and campaigns to design an economy without any fossil fuels and to achieve this goal by 2050. These are the 3 strategies, and they are titles of corresponding books, which I show here. The first one is called Plan B by Lester Brown, the founder of the World Watch Institute. The second is called Reinventing Fire by Amory Lobbins and the Rocky Mountain Institute. And the third one is called The Third Industrial Revolution by Jeremy Rifkin. Now, these are 3 roadmaps in great detail for going beyond fossil fuels. And since they involve systemic or eco-design solutions, they solve not only the urgent problem of climate change, but also many of our other global problems. Degradation of the environment, food insecurity, poverty, unemployment, and other problems. Together, these 3 systemic strategies present compelling evidence that eco-literacy and the systemic understanding of life have given us the knowledge and the technology to build a sustainable future. What we now need is political will and leadership. And again, I'm delighted that you have this political will here in Costa Rica, and you are a model for the world. Thank you very much.
Vamos a conseguir un grupo para ver si se puede abrir un periodo corto de preguntas. ¿Sí?
because with a few colleagues in California, I founded an organization called Center for Ecoliteracy. And in this organization, over the last 20 years, we have developed a special pedagogy to teach ecological literacy, ecology, and to teach systemic thinking in schools. The pedagogy involves, first of all, to integrate the school into a community. Because if the school is fragmented, if the geography teacher does not talk to the English teacher, who does not talk to the mathematics teacher, then you cannot have systemic thinking and ecological knowledge in the school. So what we do first of all is to build community in those schools. And then we build a learning environment in nature, for example, a school garden, where the students plant vegetables, they observe the life cycles of the plant, they observe the change of the seasons, the cycles of water, and so on. And then they harvest the plants, say salads, vegetables, and they cook food in the school kitchen. And in California, we have a very diverse student population in our schools. Sometimes they speak 30 languages at home, the kids in the schools. And so the cooking lesson also becomes a history lesson and a geography lesson. And sometimes there might be a Vietnamese girl who brings in her grandmother, who then cooks, shows them how to cook a typical Vietnamese dish. So it's an integrated education, cultural, ecological, and humanistic. And we have a website which is ecoliteracy.org, where you can find books, curriculum materials, and so on. Now, we do not work in universities, but there is a similar organization in Boston, in the US, and they are called Second Nature. Second Nature, and they work with over 300 colleges and universities to include teaching of sustainability and ecology at the university level. Okay? Yes, we need to get the microphone.
Buenas noches, gracias. Quería su opinión respecto a este tema. Hay un pensador y algunos budistas alemanes que toman el pensamiento de un hombre para tratar de explicar el sistema jurídico y la clase social. Plantean que los sistemas jurídicos funcionan como un proceso de autobellezas, donde se establecen comunitariamente comunicaciones y justifican que el sistema penal debe intervenir cuando las conductas de las personas se entorpecen esas expectativas de comunicación, y que los sistemas jurídicos son naturales todos a cada sistema. Este es un pensamiento que, por ejemplo, se ha proyectado fuertemente en los días de la y un poco su opinión, un poco de crítica sobre el respecto, porque ¿cómo ve usted esa proyección, esa interpretación? ¿Me puede explicar jurídicamente también cómo funciona el sistema a través de las redes? Gracias.
Can you keep the microphone for a second? I'm sorry, I have never heard of that, so I find this very interesting. So I cannot answer your question, but who started that? Is there a particular jurist in Germany who started that movement? Do you know a name?
Sí, claro, muchas personas.
I see.
Hay dos grandes pensadores, Joxy y Jacob. Joxy trata de justificar el sistema sobre propósitos, cada fin del sistema. Establece un fin establecido. Jacob lo trata de justificar por sí solo. El sistema jurídico como un producto autocoyente y la responsabilidad de las personas cuando digamos intervienen las expectativas de la comunicación. Tiene mucha producción y puede tener diversas consecuencias.
Well, thank you very much. I will read up on it. Next time I come, maybe I can say something.
Muchas gracias, muy inspiradora la charla. Tengo una pregunta respecto a cómo se producen los cambios desde esta perspectiva sistémica, porque estamos en un momento de transición importante. Siento que es un momento donde tiene que haber un cambio y quisiera saber cómo desde la perspectiva sistémica se ven los cambios, porque desde la perspectiva de Descartes, bueno, la mente produciría un cambio, el pensamiento produciría un cambio. ¿Cómo se producen los cambios más rápidos de la teoría sistémica?
Yeah. Thank you. This is an important question, and this is something I left out of the lecture because I didn't have enough time. But in the book we talk a lot about this, and the key word is emergence. Emergence is now a technical term in science, which says that in a nonlinear system there can be a disturbance from the outside. It doesn't even have to be big. And the system may pass this on through feedback cycles and feedback loops and may amplify the disturbance more and more and more until the system as a whole becomes unstable. And when it is unstable, at this point of instability, it may either break down or it may break through to a new kind of order. And every novelty that emerges in nature is created with this dynamic of emergence. And this has many important implications for human communities, for leadership, and so on. Let me just mention that there are two kinds of leadership that organizational theorists talk about today. One is the traditional idea of a leader as somebody who has a clear vision, communicates it well, articulates it well, represents it with passion, and so on. But then the other kind of leadership is leadership that facilitates emergence, which means that prepares an environment in which creativity and emergence can take place. So these are important questions, but this would make a whole other lecture to go into detail. Thank you.
Hi, good evening. Thank you very much for your presentation.
Okay.
Yes, I'm fascinated with the concept of eco-literacy. It's the first time, but as an elementary school teacher and university teacher, I believe that the special pedagogy that you are developing is going to be very helpful for us to plant these seeds in children and also in adults, if we are working with colleges. But my question is about a group of society, civil society, that I don't think is tackled right now, and it's very important, is what about the social responsibility of big enterprises and businesses that still work with the philosophy of consumerism and productivity and, more about exploitation of resources, and their target probably at this moment is more about revenue, generating revenue rather than protecting the environment. How are we going to reach that big, huge portion of society that is impacting our world?
Well, this is what the last part of our book is concerned about. And we have about 200 pages. I just showed you these 3 books that are sort of the sources. But we talk about economic inequality. We talk about redefining ownership, moving from extractive ownership to regenerative ownership. And by that, we mean new types of ownership design, of collective ownership, cooperatives, and so on. And so we go into a lot of detail, but there's no one way of solving this problem. There are many approaches that need to be done. And ecological design is one of them. You know, redefining corporations is another one. So this is a big subject, but we deal with it in great detail.
Buenas noches, profesor. Muchas gracias por su charla. Pero hay una preocupación muy grande, que es cómo mantener el crecimiento indefinido. Cada vez que hay una crisis económica en el mundo, salimos de la crisis, consuma más, compre más, y si no compra, no salimos de la crisis. Entonces, se forma un círculo de producción cada vez mayor. Y entonces, ¿de qué vamos a vivir 7.000 millones de personas en el mundo y creciendo? ¿Cómo se hace para mantener activo, que no haya desempleo y tratar la pobreza con este número insólito de seres humanos en este planeta y creciendo a un ritmo incontrolable?
Well, this is what qualitative growth is all about. Because if we change from this extractive, quantitative way of growing to a qualitative way of growing, enhancing the quality of life, we would have enough resources to live on. The reason why so many poor people don't have resources is that the global capitalist system has engineered a systematic transfer of wealth from the poor to the rich. So the rich get richer, the poor get poorer. If we change this dynamic, and this is what qualitative growth is about, there's enough there. As Gandhi said in India, there's enough for everybody's need, but not for everybody's greed.
Buenas noches. Quisiera saber si usted considera que Fomar Talante tiene alguna importancia, sobre todo en la primera parte de la exposición, que no aparece mencionado. Y la segunda parte de la pregunta es si usted ve alguna relación entre el pensamiento sistémico y el pensamiento complejo, sobre todo desde el Morán, porque a veces pareciera que el pensamiento complejo es una cosa y el pensamiento sistémico es otra. Solamente, gracias.
Well, in the talk, I do talk about Bertalanffy and this notion of open systems, and I'm sorry to say that I don't discuss Edgar Morin because I don't know his work well enough. Unfortunately, in the Anglo-Saxon world of science, in England and the United States, there is a sort of a gap between Anglo-Saxon authors and Latin authors. So, you know, French, Italian, Spanish authors are not well known enough in the American literature and the English literature. And since I grew up in this literature, I do know Edgar Morin's work a little bit, but not enough to discuss that. So that would be very interesting to investigate.
Quisiera hacer dos preguntas filosóficas. Primero que nada, me interesa saber cuál es su punto de vista acerca del concepto de la felicidad. Y segundo, quisiera saber cómo relaciona usted el concepto de felicidad con el concepto de bienestar.
Well, I must say, I have been in discussions of happiness, especially with the developments in Bhutan, where they have this happiness index. But I haven't really thought about this very much. And I can only tell you something about personal experience, and that is that happiness is not a continuous state, but it's a fluctuating state, just like health is a fluctuating state. And in fact, come to think of it, in the book I have a chapter about the system's view of health, and I'm saying, I'm giving a systemic definition of health as a state of well-being that arises when there is a dynamic balance among the various components of the organism, as well as between the organism and its interactions with the social and natural environment. And I'm just thinking now, as you ask this question, that maybe this can be applied to happiness too, and you could have a systemic definition of happiness along those lines. Thank you for the question.
Bueno, algo hemos sabido del tema de la alopoiesis y el planteamiento que tenía Maturana y Varela con respecto precisamente al fenómeno de la autopoiesis en lo social. Y ellos se negaban a hablar de autopoiesis en lo social, sino que plantearon la alopoiesis. ¿Cómo ve usted, digamos, la ampliación o profundización que hace Luhmann a partir de eso?
Well, I'm aware that the extension of the concept of autopoiesis to the social domain is controversial, and there have been long discussions. And in our book, we refer to these discussions and give references and so on. And what my personal position is that when I try to construct a synthesis, I take certain aspects from certain theories and integrate them into a coherent framework. If there are other aspects of the theories that don't fit in, I leave them out. And so the framework may not be completely consistent, but it's a first try, you know, it's a first attempt of having a coherent framework, and I leave it to others to improve it and modify it. I do not always agree with Luhmann, but I do not always agree with Maturana either. I think I pretty much agree with Varela on pretty much everything, but maybe this is because I knew Varela very well, and I spent many, many hours discussing things with him. I also know Umberto Maturana, but not that well. And so my synthesis just takes certain points and tries to integrate them.
Thank you. I understand that you have been in the country for a few days, and I wonder, in the context that you have had in our educational system and talking to people and students and people here from the university, what are your impressions? How are we doing? Do you have any special recommendations? Is there any area that you consider the one that we need to work the most? Thanks.
Well, I've been here for a week, and this is the first evening that I go into a university and talk to students and professors, so I haven't had the experience. I came for a meeting of an organization called Earth Charter International, and they have a council, like a board of directors, and I'm part of that. And so we had 2 days of meetings last week, and then we had a public event about leadership and the Earth Charter. And so my contacts have been mainly with NGOs and some businesses and not so much with academics and universities. But I can just tell you some general impressions. I didn't come here ignorant of Costa Rica, because Costa Rica is, in my circles, is very famous. And I've heard for years and years that you don't have a military and you have ecological awareness and you do all kinds of wonderful things. So I expected something like that. What I was very impressed by is how nature is protected and enhanced, that you see plenty of vegetation everywhere. In the first 2 days I went in Punta Leona to the Playa Blanca, and there's a restaurant there where all the trees of the area have been preserved. And in fact, the structure of the restaurant was built from fallen down trees. So very, very careful, very sensitive to the ecology of the place. And I also read many signs that said, for example, on that beach there's a sign that says, it is forbidden to take anything from the beach. No sand, no mussels, no plants or marine animals. And then it says, this wetland is our life. Now that, I find this very, very impressive. This is really the model of how the society should be organized. I have been surprised, to mention something negative, I've been surprised that there are very few, if any, electric or hybrid electric cars. I haven't seen any. And the traffic problem has not been solved. So I think this would be the next step. And so energy and traffic would be the next step. And there are solutions, you know. It's not that it can't be solved. But on the whole, I'm very impressed by what I've seen, and I'm staying the rest of this week, and I look forward to meeting more people and having more discussions. Okay.
Señor Capra, muchas gracias por estar acá. Es para nosotros un honor. Y bueno, me parecen muy positivas sus apreciaciones sobre Costa Rica. Sin embargo, como ciudadano costarricense, creo que individualmente y como sociedad nos queda muchísimo camino por recorrer en cuanto a la sostenibilidad. Por ejemplo, ahorita estamos o seguimos haciendo represas hidroeléctricas.
Disculpa, no tenía la traducción. ¿Puede recomenzar?
Con mucho gusto.
Sí, ok.
No, le decía que gracias por las apreciaciones. No obstante, como ciudadanos y como sociedad nos queda muchísimo camino por recorrer en lo que es la sostenibilidad. Por ejemplo, seguimos creando montones de represas hidroeléctricas a lo largo del país que lo que hacen es matar las redes sociales de campesinos y de gente que vive en torno a los ríos. Seguimos con eso, incluso en ríos tan importantes como el río Salle, que es uno de los ríos más limpios de Latinoamérica, está en proyectos, en lista de convertirse en proyecto hidroeléctrico. Entonces, digamos que se maneja un doble discurso. Por un lado ve uno un montón de jóvenes, que eso es, por lo menos en mi percepción, siento que la juventud y la niñez van con una visión diferente y que realmente uno encuentra jóvenes dispuestos a dar hasta la vida por la naturaleza. Entonces eso me produce una gran esperanza. Pero está la otra parte, que es la parte del interés comercial, que es muy fuerte. Yo le quería preguntar, ¿cómo siente usted ese nivel de esperanza que yo percibo en la juventud? ¿Cómo lo siente usted a nivel mundial?
Let me first answer at the level of Costa Rica and then go to the global level. This is something I noticed also, and I had conversations with people who told me what you just said, and who also said, and I asked them, well, what about solar? You know, Costa Rica is You know, there's plenty of sun here. Why don't you have solar panels? And my friends explained to me that it's a question of the utility companies and how they charge for electricity. And they don't want people to produce electricity, they want to sell electricity. Now, this is a problem that also happens globally, but it is a problem that happens to have a good solution, which can make money for the utility companies and have individual households produce electricity through solar panels and solve the whole problem. One of the world experts in this is Amory Lovins, and I showed his book, Reinventing Fire, and it has a rather long section on how to redesign utility companies and the whole infrastructure for electricity to solve this problem. And I suggested to my friends that if you had a high-level discussion of this problem involving people from government, people from the electricity companies. I understand that there are two big companies, both owned by the government. And if you had a group of the leaders of these organizations get together, I would be very happy to make contact with Amory Lovins, who is a good friend of mine, and persuade him to come here to Costa Rica. It doesn't take much persuasion to come to Costa Rica, so I think he could really help you and really